Welcome you all. Today we are going to do the CFD analysis of tube with a conical ring and twisted tape inside. So this is how we are going to proceed for the analysis over here. So first of all, just check out the dimensions that we are going to make use of. So these are the dimensions that we are going to make use. Length of the tube is 1000 mm. Inner diameter we are having 48 mm. Outer diameter will make it 51 mm. Conical ring with base diameter 48. Conical ring top diameter will take 24. Length of the conical ring will take 48. Thickness of conical ring will be 1 mm. So these are length of the tape will twisted tape that will take 1000. Width of the tape will take 10 mm. Then thickness of tape will take 1.5 mm. So accordingly we are going to do the analysis. So for this we have to start with the ANSYS workbench. So first of all, start the workbench here. So we are proceeding with the geometry, preparation of geometry of this one tube, then conical ring, and last one will the geometry of the twisted tape. So first of all we'll start with the fluid flow fluent option available. So geometry will use the new design modular. So first of all, set the units, that is to mm, then click on any one of the plane. Just carefully observe red, green and blue. So red will be X, green will be Y and blue will be your side. So as we need to prepare the tube, so we'll go with the primitive as cylinder. Right now the cylinder is oriented in Z direction. I don't want this to be in Z direction. I want this to be oriented in X direction. We'll make it X as 1000, Z will make as 0. Radius I need is 24 mm over here, and accordingly we'll proceed. So we'll make this as a add to frozen so as to have a transparent object and make it generate. So this is a solid object I have generated. I need this to be hollow from inside, so we'll make it some thickness specified 1.5 over here and make it generate. So now it has become hollow from inside. So this is a basic geometry of tube we have created. Now it's a time to create a ring. So we need a cone over there. So again this cone is oriented in Z direction. I don't want this to be in Z direction, I want this to be in X direction. So we'll make it 48. Then Z component will make it 0. Base radius I know it 24 as it is. Top radius I will make it the 12 over here. Then again additional thing which I want is you have to make this as a hollow from inside. So let's check out the conical ring. Thickness I will take it 1 mm. So we'll make this as a 1 over here and make it generate. So one object will be generated. Just take a look of the object so that the thickness are been proper, otherwise it is likely to create errors when we are proceeding for the we can say field operation. So first a conical ring has been prepared. I need some more number of such conical rings, so I will make use of pattern command over here. So we'll select that solid, make it apply, and then select the direction. So if I select the YZ, so this is the right direction I have, make it apply. Then total dimension is 1000, so I will specify somewhere around 200. Number of copies if I require this is to be equal to 4, so we'll make it. Now you can see the total of 4 and 1, this is 5 copies has been generated. So next thing is I want to shift this somewhat towards X, so I will change the origin component over here is 75. Now just check how the object has become now. So now next thing will be to make this as a to make this geometry to be uniform. I need to make use of one operation which is called as the boolean. So we'll make this as a boolean operation. Select each and every okay, so make it apply. So 6 bodies I will make it unite. So now you can see this bodies become unite. So if you want to specify different material for conical ring and different material for tube, in that case you may avoid the boolean operation also, but I want to make sure that there are no such errors while filling the fluid inside, and that's why I'm making this one. So now conical ring has been prepared. Now it's time to prepare the twisted tape. So for this I'm just changing the orientation. So one more time I have to go to sketch option, select a rectangle from here, draw a rectangle over here. So we'll specify the dimensions. So this is 10. I need this to be equal to, this is, I need 10, sorry, this is 10, this is, I need to be equal to, sorry, not 5, this is to be equal to 1.5. Just take, okay, make it cancel, select this and this one, so as to specify dimensions properly. Make this is a 0.75 so that it will be at the center. Similarly, this is the first part, then this one and this one, to make this dimension as a uniform, that is at the center. Now it has been shifted to the center, make it okay. Now this is the first part which is related to the profile we have generated. Now it's time to generate the path. So where I need a path, I need a path along this direction. So we'll click on XY plane and try to draw a line from this center. I need to have horizontal line, ensure that this to be horizontal. Specify the dimension. Here I will specify again 1000, make it okay. So now it's time to use a sweep operation. Okay, just a minute. So what is your profile? Profile will be what we are generated in sketch 1, make it apply. Path will be what we are generated in XY planes, that is sketch 2, make it apply. Then make it add to frozen over here. Next thing will be twist. I need some turns over here. So say for example 5. Then as a thin surface, I don't want this as a thin surface, so we'll try to make it generate. So you can see a twist has been prepared. So you can see from this side also a twisted portion that has been prepared. So this is how the things are. Now it's a time to prepare, it's time to fill the fluid from inside. So what we have to do is you have to select the internal faces. So by that time I will make this to be separate so that I can visualize in the better way for the internal parts over here. So slightly take this with a different angle, and yeah, so go with the fill operation, select fill and select all the cavities. So try to select the internal parts as far as possible. Try to have the different orientation so that the things are visible in the proper way. Ensure that each and every face has been selected, otherwise that is likely to create errors while we are doing the fill operation. Now again we are going with the other direction and we will try to ensure each and every face has been selected. So slightly zoom in so that you can see each and every face, as well as select the internal part also. Ensure that you have selected each and every layer which is available inside, otherwise it is likely to create errors when you are doing the fill operation. So make it apply, you can see this one, and make it generate. So once if it is right click, you can see that the operation is successful. Now you can unsuppress this one. So this is how this geometry that has been prepared. So this is my we say tube, copper tube. So this is a twisted tape. Then next one, this is the fluid, so I will specify this as air. So right now 3 bodies are there. One it is copper tube, twisted tape, and this one air. Why I am doing the name selection over here itself, because it will help me in when I am doing the further analysis, or when we apply the boundary condition, that time it will be useful for us. So next thing will be to save the work, which is very important, because sometime a power failure can occur, and that's why it is very important that you should save your work. So writing here CFD analysis. So give the proper name. So next thing is whatever we have done, it should be done within the geometry itself. If any errors are there, has to be rectified before proceeding for the meshing part. Otherwise later on it may go on to create further errors. So this is the first thing that is been completed. Now it's time to move to the next part that is related to your meshing. So click on edit. Then so what we are doing in meshing is we are giving some name selection over there. We are doing the name selection and then we are proceeding further. So first of all I will generate the default mesh so that it will be helpful for us to we can say reduce the computational time which is required over here. So first of all, giving the name selection over here on the this outer face. So this is going to be heater. So I will specify as a heater wall. This is going to be my inlet. At the other end it will be going to be the outlet. So three things are there, one heater wall, then inlet, and this one is outlet. So make it generate. Carefully check which one is inlet, outlet, and heater wall. So once more make it update. You will see mesh translation to the fluent was successful. Now you can proceed further. So this is the first part which is related to your mesh. Now go back to your workbench window, then click on edit part. You can make it double precision and you can select the number of solver processes as per your configuration. Make it start over. So now the phase will be to apply certain boundary conditions. So this is the important thing. Another thing is we are the temperatures is going to be vary. So that is we say that's why selecting transient. Gravity will be of no such thing as it is a horizontal pipe one. Still I am specifying here as a gravity. So next one. Here in model I will select the energy equation, that is will make it on because I need to apply some temperature. Rest of the things I'm keeping as it is, not changing much things over here. So first of all this one, this fluid will take as it is. So instead of, so I will select a copper one. So we'll select copper, close this one. So this is the first, you can see copper has been generated. If a twisted tape, if you want with a different name, different material, so you can select that also. Say for example if I want solid, go to the Fluent database, then this is solid. Say for example if I want this to be of steel, make it copy, then just a minute. Okay, just check it out, one steel is there. So you can check, cross check it with the steel, copper, and next one is if you want you can specify different material also, but I'm not going to do that. Then going for sales one condition, nothing Here copper tube and twisted tape, so these are the three things will be available. Now inlet, I am going to specify some velocity. Say here I am going to specify velocity is equal to 2 meter per second. Make it apply, then make it close. Then a wall copper tube, I have heater wall, so we'll make it some temperature. I will apply some temperature over here. Say for example, if I apply 340 Kelvin, make it apply and then closes. So this is only two portion where I applied the boundary condition. Rest of the places I'm not doing anything. So first of all, this is the thing which we have done. Now next one is to proceed further. Now this is inlet outlet, then reference values. We'll start it from say inlet. We have to tell the computer from where to start. Say inlet. So zone will be the air zone. Then go to the initialization. Take it standard initialization. Make it from inlet. Make it initialize over here. Then you can go with the calculation activities. You can specify some value over here. Say for example, if I specify 10, then you can set the animation also, but I'm not going to do that over here. So next one is run calculation. You can specify some value, say for example 500 over here. Then you can go to the graphics, say what you want to visualize, so accordingly you can select. If you want to specify the contour here itself, you can select the contour of say for example temperature, select wall temperature where you want to visualize, inlet outlet and all this walls, say for example. So make it save display. So this is how the things which can be done. Now next one, if you want you can specify, or you can skip this task also. Next thing is, if you want your path lines, you can go here and particle variable you can specify velocity, inlet we can have outlet, and then whatever the walls we have you can specify over there. So make it save display. So this is how the things which go on to be there. So you can make it color map as exponential also if you want. You can change these conditions later on also, not an issue with this case. So the next thing will be to specify the number of time steps, then the time step size 0.01 I am selecting here. Then you can click on the calculate over here. So this will definitely start our operation over here. So this is the first thing that again, so this will start our calculation. You can just check it out your residual. So it will take some time, so based upon that. So we have started with the preparation of tube, then we have prepared a conical ring, then we have prepared a twisted tape, and now we are going to visualize the result, how this will happen. So it can take some time depending on your system configuration. So we'll wait for this result, the calculation to complete, and then we'll see what the results are being coming. So try to take some more values so as to visualize it in better way. So try to have more number of iterations. I have taken it's 500. You can take it somewhere around 1000 or so also. So you can check your CPU speed also. So how much percentage utilization is there. So we can see 35% it has been used. So it will take some time. Once this process is completed, we'll see the result. So you can check it, still it is running, so it has taken some time. So approximately 63% has completed. So once this has been completed, we'll come back. So now the calculation has been completed. So this is the first thing that has been completed. You can click on save button. You can click close this window also, because these are not required anymore. Okay, so design modeler and meshing, this is also not required. You can close it. This is also not required, you can close it. So last part is just related to your result. So we need to visualize this in better way. So first one, inlet outlet, we will specify the rendering, that is 0.9 over here, make it apply. Outlet will specify here again as a 0.9, make it apply. Then heater wall copper tube, make this as a 0.9, make it apply. This one copper tube, again make it 0.9, apply. So this is the first part, that is pinned over. Then twisted tape, you can, for your better visualization, you can provide this with the help of different color combinations. So I may specify this with the help of black, say for example, make it apply. Okay, so I have converted this tape into the black color so as to have better visualization for this one. Now first one, to specify the volume rendering. So if I want to visualize the temperature contours, so specify temperature here. So I will specify user fix because I need somewhere 300 to somewhere around 420 or 450 Kelvin. 450, make it apply. So you can see the contours of temperature on this side. The default legend, you can change this appearance also, you can make it fixed over here. Number of values, you can make it 10 over here, and again you can say change the aspect ratio also, like this one aspect ratio, you can make it less. Size you can increase to 1. Its location also you can change it. So this is how first of all we'll observe the temperature contour and the temperature, and then we'll see the remaining things. So time step animation, you can go to this part as well. You can specify this first one, go to time step animation. You can just click over here and you will be able to visualize the things which are there. So if you click here, we'll see what variations are been taking place. Just visualize it from the start here. So the black one, it shows your twisted tape, so you can see the temperatures that start rising over here. Additionally, you can save this work with the help of save movie. So rising in temperature, that can be easily visualized. So we are up to 500, so it may take some time to visualize this in better way. You can additionally save the work, save the video also. You can see some changes in the color combination. The fluid which is coming from here, it is initially have low temperature, then as soon as it is in contact with this, the temperature starts increasing because the fluid is moving along this tubes over here, and that's why you can see the temperatures are higher on the outlet part. So in this way visualization can be easily done. So this is the first part of visualization. Second one, I will just stop this one and take it to the end point. Just check it out what color combination are changing. You can see the red zones. Now this is the one part which we have seen with the animation, time step animation. I will go on to use the streamline also. Just check it out here. I will start it from inlet. Sorry, this one not inlet. Make it apply. Okay, now I will just slightly go with this one, sweep animation. Then I will select the symbol size to be smaller value over here, and I will visualize this one, how the fluid particles they are moving through this channel. You can see this is coming, so the direction of flow you can see, and in between that they are taking the heat from the copper tube. So in this way the simulation can be visualized. You can additionally save this work in terms of the image files. So this is all regarding to how visualization can be done. Additionally, you may prepare the chart also with respect to the length of your, we can say, cylinder. So what is the temperature here, what is the temperature here. So for this you can select a line, make it over here. So point 1 you can select 1250, sorry 1.25, sorry 1. Okay, you can make it 0 to 1, make it apply. Then you can go to the charts option here. Then in the data series you select line and go to x-axis. On x-axis specify x, on y-axis you specify temperature and make it apply. You will see how from 0 to say actually this is the geometry, as per the geometry. So we started with the 3D. Okay, so this is 0 and this is 1. So this in actual when we prepared geometry, this was 0 to 1. So from 1 to, when the fluid is moving from 1 to 0, what happens that we can visualize. So 1 to 0 initial temperature is less, the temperature starts increasing. So this is how the charts that can also be prepared.